Quarter 1, August 17th. Alright, let's go through this. Well, I officially re-injured my wrist. Yeah, the wrist is just can't handle weights these days. I was going to max out tomorrow, but yeah, it's not possible. And my knee's kind of hurting. I think I'm a little bit overtrained. Next week next week is vacation plus defense and everything. So next week will be completely off. So hopefully that can help me recover. Yeah, I have trouble with my left knee. It's been a while. And today I was doing just some pulls. I know like can't handle a lot of snatch, can't handle a lot of cleans because the wrist. So I was just focusing on pulls, but I think the knee was I did pretty heavy on the pull. I think I should be fine, but I think the right knee is kind of taking a beating today. So yeah, the body's breaking down. It's no longer as young as it used to be. It doesn't heal as fast. Yeah, that's that. All right, let's see. Maximum network rank. There is a infrastructure of n cities with some number of roads connecting each city. Each roads indicate that there is a bidirectional road between A and B, okay? The network rank of two different cities is defined as the total number of directly connected roads to either city. If a road is directly connected to both, it is only counted once. The network rank of two different cities is defined as the total number of directly connected roads to either city. If a road is directly connected to both, that's 1. The maximum network rank of the infrastructure is the maximum network rank of all pairs of different cities. Given integer n and the array roads, return the maximum network rank. Okay, so for this 0, 1, we have 1. For 0, I have 1, 2. For 1, I have 1, 2. So, no, 1, 2, 3. So in total, it should be 2 plus 3, 5. But this one gets counted twice. So isn't that just to find the total number of things connected to 1, right? And total connected to that, and then add them together, then minus the 1 if they have connection. Right, so this 1, 2 have 1, 2, 3, 1, 2, 3, so 6 minus 1 would be 5, right? So yeah, I think this one should not be that hard. All we need to do is go through everything and, find how many they are, and then when we return the answer, we just need to make sure that if these two has a connection. How do we make sure these two has a connection? I mean, we don't, but we can turn roads into, let's say, a set. Oh, does Java has set has a not set? Java has tuple? No. Java set. I mean, you can do let's do set of tuples. Is that collection of pairs? Abstract map, simple entry. What? Oh crap. Oh. Oh, map.entry. Immutable pair, that's what I want. Entry, map.entry, key value. No, that's not. Hold on, let me try it again. Set of tuples. Tuple in a set. Just keep reading. A pair. Oh, it has to be Apache Common Library. I never go that far. Yeah, you have to write it yourself, and you have to write hash. I don't know. I mean, what do you think? I don't know. I want to do a set, but edge, right? It's basically an edge. I basically want to see an edge. Edge. Or you can just do graph. Alright? We can do graph. If we do graph, it's going to be not a hash map. But if we do graph, it's also difficult to check. I just want to know that these two, there is an edge between this and this. What would be the best thing to get to this? And without creating a new data structure. Screw this. I think I'll just write a separate one. I'll just write a separate one. So I think it's Java set of tuples. They don't have a tuple. Not possible. Okay, now to create one on our own. I think I'll use this one. This one. Hash code. What's this hash code? Java hash code override. You must override hash code in every class that overrides equals. Failure to do so will result in a violation of the general contract for hash code, which will prevent your class from functioning properly in conjunction with all hash-based collections like this, this, and this. If we override equals without override, and I tend to use, then how do you compare them to be equal, right? So int hash code, basically we just hash this. Important field. Okay. All right, I don't have to read through this, but basically this is what I'm gonna do. I will create my own class, which should be simple enough. We say class edge, right? And then we say private final a int a, my bad. Right, private final int b edge void, public void. Right, this is the int a, int b. This dot a equal to a, this dot b equal to b. Right? Is this not right? A might not have been initialized. I was just trying to follow this. Private, public. This. Yeah. I think should be fine. Oh, my bad. I think I got the construction wrong. But hold on. Okay. Oh, look at that. Look at that. I got it wrong. This is the constructor. Okay. Now we're gonna override int hash code. Right? And they probably tell me to override. Make this public. Okay. And then we probably have to override public int. Yes. All right, hash code. How are we gonna hash it? We're gonna hash that's okay, however we want to hash it. You just need to make sure it's unique. Times 10 plus the second one. Ooh. Times 10 plus the second one. Nah, let's do return a times, because I want, because the second one can be at most as 100. So to avoid, so it's actually time 100, right? As one will be 1,000, right? At time 1,000, so I have enough space to do this. Okay, so we have edge class. Then we can say set edge should it be hash set? Wait. Oh, I forgot. Set in Java. Yeah? I don't understand. Set something. Edges shall equal to new hash set. Oh, I didn't import it. Okay, that's fine. I can just java.util.star. Okay, so that's the edge. Then what do? Then we say we need to count, right? We need to count. So we can say int this edge counts equal to new int n. Okay, then for int this e of roads Okay. Then we can say edges dot add new edge e0 e1 and edge counts e0 plus equal 1, edge counts e1 plus equal 1. Okay. Once we're done, we need to find out the maximum of edge count. Oh god. Not the maximum, the top two. Well, because and so I think I would just do arrays.sort edge counts. Okay. When you sort it, probably we can do reverse. Wait, how can I have a comparator? Reverse order. Well, no, that's not right. Oh, I forgot how to sort reverse. How to sort reverse. Java sort reverse. Collection.reverse order. Collections.reverse order. My bad. I think it should be collections.reverse order. What's wrong here? Oh. It's not an object. Alright. Can we just do comparator dot comparator? Wait. Comparator dot comparing int. Yes. A minus A. Is that right? Cannot be applied. Huh? What do you mean? So I have to compare integer. What about 0 minus? What the hell? Huh? Oh, wait, hold on. Isn't that shall do? I forgot how it's done. Comparator comparing int comparator Java. Comparing int. I did it like last time, but I forgot how it's supposed to do. Let's see example. Well, for one thing, this is comparing. Yeah, that's not what we want, right? It's collection.sort. As list. Now I want arrays.sort. Okay, arrays.sort. Yes. To object. I don't like it. I don't like it. Oh, arrays.sort is it have to do this way. All right. Screw this then. Screw this. We are going to, because this is what I can control. So I just do this way. Integer, it's fine. Because it'll work. It still works. Then I can, yeah, then it's still, this is still not right? So, but I mean, it's, I think I can just do this one dot sort, stream dot sort. No, that's not what we want. We still have arrays dot sort, edge counts, collections dot reverse order. But how do we use the compare int? I use it once, but I forgot how to use it again. Comparator. Comparator this dot reversed. I did some comparator compare int in the past. Compare int to int function, key extraction. Extraction int. So it is extract returns. The function used to extract the integer sort key. So I think I remember it's a tuple. Right, we can use tuple for this, but this cannot. But it's fine. I just want this, right? And yeah, I mean, actually, we don't need this, but it's fine. Now we're gonna pick the first two, right? So we say int res shall equal to edge counts. Oh, but you don't know which one is which. Oh. All right. Yeah, sorry. New int n2. So we add an edge count. This we need to put. Actually, hold on, because I want to, nah, I think no, I need to create a new thing and then sort. No, the edge count is fine. Edge count actually edge count is fine. We can even use int, right? Edge count is fine. But after edge count, then when we do the sort, it's different. So we need to say int, right? This shall in the sorted edge counts shall equal to new int n2, right? And we say for int I equal to 0, I smaller than n, I plus plus. We're going to say sorted I equal to new int count. So edge counts I, and I is we have n of them, so we put them in and we'll sort this. Then we can use comparator dot comparing int tuple. Yes, there we go. Tuple, we can compare 1, right? So this shall equal to sorted counts n minus 1 plus sorted counts n minus 2 1, right? And then we say if new edge, edges dot contains new edge sorted this and this contains all edges that contains new edge this and this, because it could be reversed, right? If this is true, then rest minus minus minus, and we'll return rest. All right, here we go. Okay, let's give this a shot. This one, right? Oh my god, this one looks so ugly. Ooh, that's not right. Output 5, 7, 13. That was bad. Huh? Wait, hold on. So is these two has to be, huh? Why is it not right? Two cities is defined as the number of to either. Output 5 should be 4. 5. Well, that's 1, 2, 3. That's 1, 2. That's 1, 2. I say every time an edge is encountered, a count plus 1, right? So 0, 1, 1, 1 will be 3. And then I will sort. It's every time I will new int sort it at this position. I'll put two values, which is the count. Oh, I go count first. My bad. Let's go count first. Oh, sorry. Nah, I think we'll change too much stuff. We should just change this. This. That should be right. All right. Now we have serious issue. It's still not correct. What the hell? Did I get this one wrong? Five, 6, 5, 4, 5, 5. That's, yeah, that ain't right. It seems like this part that contains has trouble. The set will add a new edge. Does the hash code get it wrong? Oh, gosh, I see what's wrong. And I see what's wrong. Oh my god. That's why you shouldn't do it this way. That's why you should get A and B out. Okay? You need to get A and B out. Now we say int A equal to sorted edge counts n minus 1. 0. And int B equal to sorted edge counts. Yeah. N minus 2. That's why we got it wrong. And once we have that, this is just going to be, no. We can easily say it's AB, or contains new, this is going to be BA. Right? See? So much easier. You gotta be kidding me. What? Alright. Now I don't know why. This looks right to me. Check. Int n equal to 4. Int rows equal to new int. Yeah, I have no clue. I have no clue what goes wrong. 0, 1, 0, 3, 2, 1, 3. Like, what the hell? Maximum n rows. Oh. Systems dot out dot print line. Print 5, supposed to be 4. Alright. Screw you. Oh. Didn't put a, let's put it here. You know what? Actually, let's put it here. So when we enter, we will, okay, so we debug. All right, let's do this. Cannot find local variable. We don't have E. What the hell? Where is E? Roads and this. All right, can we go next? Step over, step into, no step over. Okay, edges, size is 0, edge count, perfect. Oh, int E, gotcha. E is 0, 1, edge count. All right, can we step over, step into, can we step out? Oh no. Step out, we already get a result. Let's redo this. And how resume program? How do we get it out fast? F8. Okay. One. Can I track edge counts? Okay, so 2, 3, 1, 2. Yeah, it should be 5. How about edges? Edges hash set 0, 0, 1, 0, 3, 1, 2, and 1, 3. Yes, that's correct. That is correct. and edge count, right? And then we're going to sort. Okay, and now we sort it. So once we sorted accounts. Sorted accounts. Yes, because I have 2 and 3. That's fine. And then rest shall be 5. Good. And now we just need A and B. Right? A1, B3. 1, 3 shall be in it. Oh! Well, contains has issues. That's not right. Do I have to override equal? Maybe. Maybe that's the thing I'm missing. I need to override equal. Okay, I need to override equal. So public boolean equal. Yeah, maybe I should read that. Like why both has to happen at the same time. Because if you don't override equal, it will use whatever equal to get this. Okay, this is gonna be edge other, right? Then we shall return this dot and just hash code equal to other dot hash code. Okay. Would this be right? Run. Stop. Rerun. No. Hold on. I did not override. Let me override. Equals. Wait, wait, still not right. Method does not override method from its. Wait, what? It's superclass. Oh, wait, it has to be object? Yeah, I think it has to be object. Should check the class. Hold on. Oh, I know. We have to check. Okay, so we have to check like this. If not O other instance of edge, return false. Otherwise return this. How does this one go? There we go. There we go. So we have to you have to write both. Why do I need both? All right, I need to read this. Oh boy. See, this is good. So you kind of just learn. I don't think these type of learning happens just by reading through the book. Maybe it does, but it will take time, right? Yeah. Now this one seems to be much better. I mean, we could just add both then we only need to test once, or we do once and we do test both. Yeah, I like this one better. All right, run it. Oh God, I was so confident, and it's wrong. The hell? Did not expect. Okay, I did not expect this. 4, 6, 5, 2, 3, 5, 7, 5, 7, 6. Expected 5. One, two, 1, 2, 3. Oh shoot! Yep. Sorry, because they can have. Oh my gosh. Oh my god. Yup. Yup. Yeah, it's okay. Yeah, I see why it is wrong. Damn it. So we do this, right? And then you need to get the count, right? So it probably needs a hash set, a hash map. Right, we have the counts, so we can count how many. Alright, in this case, to make it easier, I'm just gonna do add new edge, a reverse as well. Yeah, just sacrifice some space. And now we do this. We don't do any of this. Now we need a hash set. Edge counts, count of edges, hash map, integer, and an array, integer and int. Oh, that's why you have to check every single pair. Oh my god. Oh my god. I have to check every single pair to see if this pair is in it. Lordy. Don't we have a better way to do this? Every single pair? Yes, you have to check every single pair. Right? You check every single pair to see if any pair does not exist. Ah. Gordy. Alright, change my mind again. I'll do edges goes to new int. Yeah, change my mind again. Yeah, I'm in this. Go to 1. Edges E1. So basically we use this to check if its edge exists. So now we have to do, right? So count of edges, count of nodes, no edges, right? Equals new hash map. Then we can say for edge count, int I equal to, well, we can edge, not edge, node v equal to 0, v smaller than n, v plus plus. Then we say count of edges, edge counts v dot add oh, my bad. So if count of edges dot contains key, edge counts v, right? If it doesn't contain key, then count edges dot put. Yes, edge counts v and a what can do integer. No, I'll have to do array list. Okay, now I can do this new array list, right? Perfect. And then edge count edges, dot, wait, hold on. Oh, dot get, yes, edge counts v dot add v. Okay, once we're done, then we can now get a maximum sub and a second maximum, but I don't want to. Can I get Java get keys from map as array or as list? The key set to array. Oh my goodness. There's no standard way. I mean, I can do integer. That's fine. Integer sorted counts. Okay, sorted counts equal to map. I need a map. What's the map? Count edges dot key set to array. Key set to array, new integer. Yeah, that's not right. New integer, we need a size dot size. Why is this one not right? Preset arguments. Replace with empty. Huh? What does this mean? New integer 0. I don't understand. Convert the set to an array. You can use to array. It tells me to use this. I don't understand. This is an empty set, an empty array. Okay, let's just say that's right. And then we can do arrays.sort sorted counts. Right, perfect. Then we have to go through every single pair, right? Sorted counts. Oh no. Oh, well, yes, I know the counts because I can use this. Okay, so we can say int res shall equal to sorted counts. Sorted counts dot size. No, shoot. Size. No, probably dot length. -1 plus sorted counts. Sorted counts dot length -2. Right? Parameter dot reverse order. Then I just need to say 0 and 1. It's much easier. 0 and 1. Okay, now we have to go for int a of count of edges dot get what? Sorted counts 0, right? Then for int b count of edges dot get sorted counts 1, right? So for these two, then we say if I need everybody, right? Everybody. So if edges AB is equal to, so everybody has to be, as long as one of them does not have, so we just return res. Otherwise, we return res -1. All right, so this one, run this over. Where? Oh, that was an oversight. There you go. Oh, it took so long. Oh, my bad. Yeah, I forgot about this. I was thinking n, but this is the counts, sorted counts. They could be, one count or. Yeah, it could be 1 count, or it could be 0 count. Plus, why you say it's the maximum count? Yeah, maximum count. But hold on, even if it's that, that's the number of counts related to the edges, right? So you basically have 0 count. Oh my god, that's not right. Because the maximum count can be the same. All right. Yeah, and how do we get this right? I am not quite sure. Yeah, how do you get this one right? I think that's wrong. Like this one has 3, this one has 3, this one has 3, this one has 2. Oh, I chose this 2 and these 3. I got it. So yeah, this is not right. Oh my god. Such a simple problem. Took so long. All right. Again, we get accounts and then we do this mapping. That's all fine. Right? That's all fine. I think counts 0. Even if it's a 0 count, right? Even if it's a 0 count, I shall still produce something. Then if it's a 0 count, then this one will only have 1, right? Okay. So we can sort. That's fine. That's fine. Up until here is fine. This below is wrong. Okay, here's what we need to do. We need to say yeah, there are a couple of situations, right? The sorted counts must be at least have 1. So we say we take the maximum, right? This is the maximum, and what we need to do is get the maximum and the maximum depending on how many we have in the maximum, because it has to be 2 nodes. So if the maximum has 2 nodes, it will be like that. Okay, so if count edges dot get sorted counts 0, right? If this dot length, size, is larger than 1, we have more than 1 nodes that have, then they can pair or pair them up, right? Or pair them up. Then we say, let's do int res here, okay? Then we say res equal to 2 times sorted counts 0, and for int a of count edges dot get sorted counts 0, right? And then for int b count edges dot get sorted counts 0. If edges ab is equal to 0, return res, otherwise return res minus 1. Else, okay, only one node has max number of edge counts. Then res equal to this, and there gotta be another one, right? There had to be. Because we have 2 nodes, right? 2 nodes. So if 1, the count is larger than 1. If the count is larger than 1, means it's equal to 1. If it's equal to 1, it gotta have 2, right? It gotta have another sort of count. Another sort of count. So we do this, then, well, this is equal to 1. So basically this, yeah, this one's not necessary. The outer layer is not necessary because we only have 1. Right, we only have 1. So for B, this is just going to be count edges dot get sorted counts 0, 0. What array type expected? Yeah, I know we get it, array type. What's wrong again? Count edges. Oh, do we need to get 0? Okay. All right, try it again. Gosh. Not tough, but I don't know. Oh my god. You gotta be kidding me. Second one is wrong. What? What the hell? Oh, I know. If A is not equal to B. My bad. Forgot that. Alright, come on. This one should be right. God. Took so long. I blame the language for this one. I mean, if I do this in Python, I guess it will be much faster. but we cannot do this. Have to learn. Have to learn. Well, struggled. This is not a difficult, okay, problem. All we need to do is to count the number of edges associated with each node, then pick the edges, pick the nodes with the highest edges. Yeah, that's why you should do the other way. But if you do the other way, pick the highest, then you don't know which one to go through. I see. So you have to sort, right? You need to know the max, the second max, and then you do the max, you do the second max. You do the max first if you have enough. Pick the nodes with the highest edges, right? And find all the pairs, find all the possible pairs. If a pair exists that does not share an edge, that pair will give us the max rank. Of course, we must, when checking the pairs, right? Checking the pairs, we must first check all the pairs within the max number of edges. If there are no pairs there, if there are no pairs in max number of edges, we go for the second max number of edges. However, Java really slowed me down. Okay, or it could be, I was not doing the most efficient. Yeah, O(n) squared, for sure. O(n) squared plus, well, we have m. M is the number of the rows, where m equal to rows dot size. I think it's length. And the rest is just gonna be O(n) squared. Yeah. Not the best. All right, let's see. What's the official solution for this? In degree nodes. Yes. And what? A set of integers. Yeah, that's fine. Oh, look at this. Compute if absent. Adjacency list, absent. Okay. What's this K? Key. New hash set. Dot add. Compute if absent. What if it's not absent? That's just adjacency nodes. Oh, wait, hold on. Computer. Oh, I see. Compute if absent. Gotcha. Each possible pair. No way, you gotta be kidding me. Current rank equals this. Get or default empty set dot size plus this. If contains this. Ugh. It's just. Yeah. And just go through. I think I'm thinking a little bit more complicated. Okay, I'm gonna change this. Okay, we can use compute if absent. So basically, this is gonna be count edges dot compute if absent key edge counts v if absent key new array list dot add v. Oh my, one line. Oh, then we sort, then we do this. Oh yeah, we did it. The difficult way. I'll use this. Seven. Now let's see if I do a stupid way. So now this is okay. The official solution just create an adjacency list. Adjacency list and iterate through all pairs. Kind of dumb, but there is a lot less overhead. Well, let's try this. I never do adjacency list. It has to be a hash map with integer and array list of integer. Graph. Don't need any of this. No, actually, my bad. We need the rows, but we don't need any of this. Wait, do they have a better way to iterate through the? Nope, there's no better way. Okay, then graph dot compute if absent e0. If it's absent, we'll do new array list dot add e1, and then we do exactly the same for the reverse. Okay, now we say for v, right, int res equal to 0 is all of this. Then we say for v, for int, so now ab, a b equal to a plus 1, b smaller than b plus plus. Yeah, let's go through all possibilities. Then res, no, int rank shall equal to graph dot get or default A. If default shall be new array list, right? How do they get the empty list? Collection.empty. Ah, nice. So collections.empty list, right? Oh, empty array. Do I have empty array list? No, there's no empty array list. Empty map, empty set, empty sorted. Wait, what? Okay, what's the difference between Java collections empty array list? There's no empty array list? Uh-huh. Yes, I know that. But hold on, what's the difference between array list versus list? Here's basically just learning Java. It's more than just LeetCode. What's the difference between the two? List is a child. Is an order collection, blah, blah, blah. Okay. List interface is implemented by the class of this, 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 and this. List is an interface, and the instance of list can be created by implementing. All of these are list, right? All of these are list. Oh, so the list, these are interfaces. This is interface. These are class. So I cannot say a new list something, because that does not work. Ah, I see. So what I need to do here, this is empty list, is correct. But this, I shall change it to list. There we go. Nice. So rank will be this dot size plus graph get or default b collections dot empty list dot size, right? Then how do I know AB exists as a path? That's why this is not a list. That's why it has to be a set. Oh god. Yep. This has to be a hash set. Hash set. And this has to be an empty set. Yep, I understand now. I understand. Okay. So rank is this. Then we shall say if graph dot get or default a collections empty set dot contains b, then rank minus, right? Then we say res equal to maximum res math dot max res and rank. As we done, we almost done. We return res. All right, let's try this one. that right? Yeah, I mean, seriously, this might actually be faster because there's just so much less overhead. I'm completely wrong. Alright. This is slower. This is slower. Nope. This is slower. Which is expected. I mean, I'm actually happy this is slower. So again, I think this shows that in Java, the overhead of a slightly more complex algo is not that much, right? It's not that big. In other words, a better thought out algo shall perform better. Right, it's the same runtime plus edges. Yeah, we can see v squared plus edges, but this is slower, right? It's a lot slower than the other two methods where we do, we have different data structures, and then we sort them, right? We get the maximum, we get the second maximum, like we do all of those crazy stuff. But I mean, overall, you can still say it scales at ov squared, but we don't have to go through all of this. And then, yeah, that's why it's faster, right? It's much faster. But it's good. Now we learn some new things. This get or default, compute if absent. It's very verbose, and I don't really like it, but it's part of the learning. Okay, well, I spent so much time on this. I don't have time for this. You want to read through that? I don't know. It's more than 1 hour. Yeah, I'll leave this for tomorrow. Yeah. All right, that will be it. That will be it for today. I will see you guys tomorrow. Adios.